My name is Jeff Stewart. I'm an architectural designer at Garrison Architects in Brooklyn, New York. Before coming to Garrison, I had a lot of internships over the summers between semesters at school, and I think that was a great experience to help me understand what I was getting into and what to expect once I graduated. And I would definitely encourage students to, do as many internships as possible. So in 2008, the Office of Emergency Management set up a What If New York request for proposal design competition that students and professionals entered and submitted ideas for how to respond to a natural disaster. A few years later, in 2012, Hurricane Sandy hit New York City and devastated the coastlines. And they set out another request for a proposal for a more specific design related to a prototype for urban housing. Garrison Architects won that design, and we designed a modular structure that could be built off-site in mass quantities and delivered to wherever a disaster might be. So typically, when you construct a building, you start with the foundations, you put in your basement or footings, and erect the structure from there, piece by piece, steel beam, by steel beam. The difference in modular construction is that the building is actually built off-site in a factory. While that's going on, you can build your foundations. So those two things are happening at the same time rather than one after the other. This makes modular construction much faster. It's more precise. There's more quality control when it comes to disaster relief housing, where you need a product that can be built rapidly. It's a perfect solution for that. Yeah, so one of the design parameters when building with modular is, it is similar size to a shipping container. There are restrictions based on transportation widths and heights that determine the size of a module. So this is the OEM prototype. The entrance is straight through the kitchen there. There would be a stairwell here with another module on the other side, so the stairwell would access two modules, and it would be 4 modules high. So you enter into the kitchen, and then off to the side is the living room, where there's a Murphy bed, there's storage containers, and other amenities. You could have a TV or internet, in this space. Off of the living room is a small balcony, which helps with solar heat gain. It's one of the sustainable features, and there's corrugated panels around this. The siding's all corrugated metal, which is durable and it's long-lasting, with fiber cement, which is also very inexpensive. All the materials on this project are inexpensive and durable, so that they can last. For a prototype for disaster relief housing, you want something that can be used over and over again. Each unit comes with a hot water heater. It's all electric. There's no gas at all. And the fun thing about modular is that when these get delivered to the site, everything you see is in the units. So the prototype's designed to be craned into place, and then they're bolted or welded onto the foundations. You hook them up to city water or plumbing, or you could hook them up to temporary tanks and generators or photovoltaics on the roof, and they can be completely self-sustaining. So if you wanted to move these, all you have to do is take out the bolts or grind a few welds, and you could lift them again and take them wherever you need to. So the idea is that this prototype can be used multiple times. And that's another reason for the durable materials, and so they're very easy to install. These were installed in about 12 hours over 2 days, and that includes the stair tower and the canopy, which is in the balcony and the ramp. So with this project, there were about 8 different pieces that were all bolted together, and that was all done in 2 days.